Hey there, y'all. Today we're going to look at 1.7 on solving systems of inequalities by graphing. And so our objective here is that you'll be able to solve systems of inequalities graphically and also be able to determine the coordinates of vertices of a region formed by the graph of a system of inequalities. Our standard that we're looking at today is continuing in ACE.3, dealing with systems of equations and inequalities. This is all going to lead up to what we're going to do in 1.8. And so we'll look at that section next on optimizing problems. But before we get there, we need to be able to solve systems of inequalities. And so let's check out the steps to solving a system of inequalities. As we look at solving a system, step one is that you're going to graph each inequality. And don't forget about the shading, right? So when we talk about graphing them, we're going to take one line and graph it completely on the graph, figure out where it shades. And so it'll shade like over here. And then we're going to take our second line and it graphs something like this. And we're going to shade it over here. And then step two says to identify the region that is shaded for all of the inequalities. This region is the solution of the system. Now, included in that is any solid lines that touch the overlapping shaded region. So if I have two lines here, this region here is where the red and blue overlap. So everything in this pinkish purple highlighted region is going to be part of our solution set. And because both of these lines are solid, all of the pieces along this part here and this part here will also be solutions, including the point of intersection. Now, if either of those lines had been dashed, the dashed line would not be a part of the solution set, and the intersection of the two lines would not be a part of the solution set. So let's go ahead and look at example one and see what we get. So in example one, we're asked to graph the system, and we've got y is greater than or equal to 2x minus 3, and y is less than negative x plus 2. Both of these are in slope-intercept form, so these will be pretty easy to graph. And so I'm going to give them two different colors here. We'll do the first one in red, and the second one is blue. And remember, red and blue make what? Purple. So the final shaded region is where our red and blue make purple. So let's graph the first one in red. So my slope is 2. My y-intercept is negative 3. And so where do we start? We're going to start with our y-intercept of negative 3, and we're going to go up 2 and right 1. And so here's my next point. Now, I know some of you are like, oh, just draw a little line and be done. But we've got to draw this line as long as we can because we need to find where these two lines are going to do what? Intersect. Okay? So keep this slope going up 2, right 1, up 2, right 1, and we'll go all the way up and all the way down this line to get it. Here's the next question. Is this line going to be solid or dashed? Remember what we talked about. Because this is equal to, we will have what type of line? Solid. So, solid line all the way here. Okay? Now, where's this line going to be shaded? We want to, again, test a point that will make sense, right? And so if I plug in 0, 0, 0 greater than or equal to 0 minus 3, because 2 times 0 is 0. And so 0 greater than or equal to negative 3. Is that true or false? That is true. So my origin would be here. So it is shaded. And so my shading would be all of this region up here, right? Again, all of that is in the shaded region, all the way to touching the line. Again, I know my shading is not touching, but that's where it would be. Let's look at the blue. What's my slope? My slope is negative 1. My y-intercept is what? 2. So we go to our y-intercept of 2. We're going to go down 1, right 1, and continue that pattern all the way through. And again, we want to do it in both directions. We want to make sure we have this line as long as we need it because we want to know where this region is for any possible solutions. Is this line going to be solid or dashed? Well, look at the inequality. It's not equal to, so it is dashed. And so my dashed line will come through like so. One thing to always remember, where they do cross, you want to make sure you can see where they cross. Now, we'll try 0, 0 again. The zeros are going to work for this one. 0 less than negative 0 plus 2. So is 0 less than 2? That is true as well. So my shading will be on the same side of the origin of the blue line. So my blue shading is all of this. So where do red and blue make purple? That's our final region. And so red and blue will make purple in this region right here. All of this is my possible solutions. Again, everything here where red and blue make what? Purple. So, one of the questions they could ask you off this question is, what are some possible solutions to this problem? And so possible solutions would look like this. It would be any point that's in this region. So for example, negative 7, 4 is a possible solution because if I were to plug that in for both inequalities, it would be a solution. It would work for both. Any point along this red line going this way, right? Any point along this red line going this way. So like my y-intercept of the red line at negative 3. So the order pair 0, negative 3 is a solution to this system. What are not solutions? So if we come up here on the solid line, now normally we think solid lines are solutions, right? But remember, it's got to be able to be a part of both regions, both part of the red and part of the blue. It works great for red. It's on a solid line, right? But it's not in anything blue, so it doesn't work. If I come over here, again, I'm in the red, but I'm not in the blue, right? If I come down here, I'm in the blue, but not in the red. And then over here, this last region over here, there's no shading, so it's definitely not a solution. If I were here at this point, it is on the blue line, but the line is what? Dashed. It's in the red region. So it works for red, but it doesn't work for blue. So this point here at negative 3 and 5 is not a solution because it's on a dashed line. Okay? So that's the key things of this section. So if you understand this, then everything else we do should fall in place. Okay, I want to set this groundwork at the start of everything that we're doing. So let's look at example 1b. Now these two lines are not in slope-intercept form, they're in standard form, but the process is the same. So we could still graph them using our intercept, so we can find the x-intercept and the y-intercept of each line, graph them, plot them, figure out their shadings and what type of line they're going to have. Or we could put these in a slope-intercept form and do the same thing. I'm going to work these in standard form, keep them in intercept form, and get the intercepts. Okay, so let's look at, again, I'm going to label the first one red and the second one blue. And if you are doing this in your OneNote and doing this in your notes, use the colors. If you're doing this on Kami for your assignments, use the colors. If you're doing this on paper and pencil, find some colored pencils or markers. This is going to help you a lot with this. Okay, so the first one, remember that we set 0 for each of the variables and solve for the other. So I'm going to get that 2x is equal to 10. So x is equal to 5. So my x-intercept is 5. My y-intercept, I'm going to get negative 5y is equal to 10. Divided by the negative 5 means that y is equal to negative 2. So I get here. So this is up to right 5. So I continue that pattern in both directions. Up 5, or up to right 5, and then down to left 5, and down to left 5. Solid or dashed here, it is dashed because it's not equal to. So we'll dash it on across. And if I need to see the intersection later, we'll add in a little bit of a dash so we see the perfect intersection. On the blue, 6x plus 4y is greater than or equal to 12. So 6x is equal to 12 means the x-intercept is 2. And we do the same for the y. 4y is equal to 12, so y is equal to 3. And so I get here. So this is down 3, right 2, so down 3, right 2. And we continue the pattern for each of the steps. Down 3, right 2. Go up 3, left 2, up 3, left 2. And this line will be solid. So we'll come straight through here, like so. And so I'll extend that red just a little bit so we can see actually where it intersects there. Now let's talk about the shadings. We didn't do either of those yet. For the red line, is 0, 0 going to be a solution? So 0, 0 less than 10. Yes, that checks out for red. So my red shading will be up here. And then we look at the blue. Is 0, 0 going to work for this? 0, 0 is greater than or equal to 12. That is false. So it does not work for the blue. So I'm not going to shade this way. I'm going to shade the opposite side, which is over here. Okay. So where do red and blue make purple? They make purple over here. And again, all of these points in this purple shaded region. And all the points that are touching on a solid line, the shaded region, will be solutions. So again, we can pick order pairs out of here and get those solutions as we need them. In this case, it just said solve the system for the inequality by graphing, so we've graphed it. Again, the question could ask for a particular solution, but we looked at it in 1A, so we're not going to go any further with this one. So let's look at example 2. And example 2 is named separate regions, and it's named separate regions for a reason. Because look at the slopes of these two lines here. So the slope of this line and the slope of this line, right? What do you notice? They're the same, right? So if the slopes are the same and the y-intercepts are different, that means the two lines are what? Parallel, right? So let's see what happens when we graph these two up. Again, these two are in slope-intercept form. So you should be able to graph these up without me, so go ahead and do that ahead of me if you can. If not, follow along. So my slope of the first line is -3/4, and the y-intercept is 1. And so I'm going to go to my y-intercept of 1 and go down 3, right 4, down 3, and right 4. It's there. Down 3, right 4, yep. So up 3, left 4, up 3, left 4 gets me there. And this line will be solid. So we'll come through like so. Now, where's this line going to be shaded? Is 0, 0 going to work? So I put 0 and 0. Is 0 greater than 1? No. So red is not here. It'll be shaded above. Okay. Let's check out blue. My slope is also -3/4 because we said that's the same slope. My y-intercept is -2. So I come to the -2. I'm going to do the same thing. Down 3, right 4, down 3, right 4. Up 3, right 4, up 3, right 4. This line is also solid here. And is 0, 0 going to work for this one? 0, 0. Is 0 less than or equal to -2? No. So it's not going to be above this blue line. It's actually going to be below. And so ask yourself, where's the red and blue making purple? You're probably asking yourself, wait, what? Well, here's the thing. They don't overlap, do they? So if they don't overlap, what's the solution? There's no solution because there's no overlap. And that is okay. There is no point on this coordinate plane that will satisfy both of these equations. Okay? So let's move on. So I want you to look at example B here, and I want you to graph it on your own. And so pause the video at this point, graph this, and look at the solution set and see if you get what I get. All right, I hope you paused the video there. And so let's look at these two. So I'm going to do this one in blue and do the first one in red. My slope is 1/2. My y-intercept is 4. So I'm going to start at 4 and go up 1, right 2, and continue that pattern all the way to both edges. And go the other way as well. Down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, and down 1, left 2. This line will be dashed because it's not equal to. Do the same for blue. Well, let's get our shading first. So is 0, 0 going to work for this? Is 0 less than 4? That checks out, so this shading is down in this direction, right? Now let's do it for the second line. My M is 1/2, my B is 2, so here I'm at 2. And so I'm going to go up 1, right 2, and continue that pattern like we did before, up 1, right 2 all the way. And then down and left the same direction. Down and left, and down and left. This line is also dashed. And so what do we see with this one? Is 0, 0 going to work? 0 greater than 2 is a no, so this line will be shaded above. Now this is where you've got to make sure that your shading marks get as close to the line as they can. Because where is the overlapping region for these two lines? It's in between the two lines, right? It's this little space here. It's not out here. It's the space here. And so when we shade that in, we're going to get this area right here in the middle. Any order pair that is in that purple shaded region, and Can it be a part of the either line? No, because both lines are dashed. Now, if one of these lines were solid, every point along the solid line would work. But because they're both dashed, only the points in between the lines will work. So let's look at example 3 here. We're going to write and use a system of inequalities to graph this. And so medical professionals recommend that patients have a cholesterol level below 200 milligrams per deciliter, so that's milligram per DL, of blood and a triglyceride level below 150 milligrams per deciliter. Write and graph a system of inequalities that represents the range of cholesterol levels C and triglyceride levels T for a patient. Now, this problem is actually easier than what you're thinking because our two variables are what? So let's first highlight here. I'm going to use orange and blue here. So my cholesterol level has to be what? Below 200 milligrams per deciliter, right? Because of the units. And so my C has to be what? Below what? 200 milligrams per deciliter. That's the units on it, right? That's my first inequality. Not as hard as it looks, right? My second one, let's highlight in blue. And a triglyceride level of what? Below 150 milligrams per deciliter. And so when we do that, so T has to be what? Below, less than, what? 150. And so in this case, we're going to draw our coordinate plane. It's only going to be first quadrant because your cholesterol level cannot be below 0 and your triglyceride level cannot be below 0. So I'm going to do C on this axis and T on this axis. And so my T, I need 150, so we'll just go 150 here and we'll make this 100 and this 50, right? So 50, 100. And on T, we need to go out to 200. So 50, 150, right? And so if I need C is less than 200, so that's the orange again. So I go to 200, right? And where is C less than 200? Well, it'd be over here, right? So my shading would definitely be this way. But where's the line? If there's only one variable, remember, our line is perpendicular to the axis that the variable is showing. So my line is going to be this line, right? With all my shading going out this way, okay? Now we do the same for the blue. Triglycerides of 150. So again, I'm at 150. I need to be less than the 150, so my shading is going to go this way. I'm not equal to, so my line will be perpendicular to the axis coming out this way here, with my shading going down this way. Now I didn't use red and blue here, but you get the idea. Where does the shading overlap? So the shading overlaps, and let's just use yellow here, in this rectangular region here. And so any point in this yellow shaded region would be a solution. Now, again, I don't want a triglyceride level 150. I want below 150, so I can't be on the blue line. Same thing with the cholesterol level. I can't be 200. I need to be below 200. So make sure you pay attention to those values. And so this is our system. This is writing the system, and this is graphing it. That's it. It's not as complicated as we make these out to be. Looking at example B is a little different than example A, but it's still the same idea. In this case, again, I'm going to use orange and blue because I have the highlighters of them. We have a Category 3 hurricane that has wind speeds between 111 and 130 miles per hour. So that's wind speed, right? So we're not dealing with an inequality that is like W is less than or W is greater than. We're now dealing with a compound inequality. So my speeds have to be between 111 and 130. Now, can the speeds be 111? Can the speed be 130? Yes. Now, if you know me so far, you know that I am a meteorology fan. I love weather. I love hurricanes. I love studying them. I love reading about them. So yes, you can be both. And so this is going to be less than or equal to here and less than or equal to here. Now, why are both signs less than or equal to? It sounds kind of weird, right? But think about it. 111 is less than or equal to the possible wind speed, which then is less than or equal to 130. So what that means is my wind speed has to be between these two values, right? Because think about a number line, right? 111 will be smaller than whatever wind speed I have, which is then smaller than the 130. If my W doesn't fit between those two constraints, it doesn't make sense, okay? So now we go with the second one. Now I will tell you that this problem's a little dated because storm surge is actually not done in terms of category anymore, but the average is between 9 and 12 feet for a Cat 3 hurricane. Again, some storms can do a little bit different. But that's neither here nor there. That's for your science class another day. All right, so storm surge is going to work the same way. So think about how this is going to write out. Again, I want the 9 and I want the 12. I want to be between them, so we're going to use S for surge. And again, less than or equal to, less than or equal to. Now, if they were to tell us that the value cannot be equal to a certain value, so let's say it has to be greater than 9 but less than 12, then we would not use the equal to parts on this. We would just use the less thans for both ends. Or if it said it could be equal to 12 but not greater than 12, then of course one side could be equal to, the other side not. Okay, so let's graph this up. So join our coordinate plane. Wind speed will actually be here. Storm surge is here because the wind speeds determine the category and the storm surge comes after the wind speed. And so our wind speeds will be between 111 and 130. Now I know this is not to scale, but it doesn't need to be for what we're trying to do here. Same thing for storm surge, 9 and 12. And so when we draw these inequalities, it's actually a little different. So let me start first with the wind speed. We want between 111 and 130. At 111, I'm going to have a vertical line because it is solid because of the equal sign. And also at 130. Solid because of the equal sign. Where would my shading be? Right here in this middle section here, right? Because where's the wind speed got to be? In between, right? And then we do it for the storm surge. And so the storm surge, 9, straight line across at 9, straight line across at 12. And where's my storm surge got to be? In between, right? So it's going to be in between these two lines like this. So where do the two overlap? The two overlap in this little box in the middle, right here. And so a Category 3 hurricane, again, it's determined by wind, storm surge is secondary, could have wind speeds between 111 and 130 and storm surge between 9 and 12 feet. All right, so been a lot here so far, but we got one last thing we're going to look at. So let's go to that now. So example 4 here, we're going to find the coordinates of the vertices of the triangle formed by the three inequalities listed here. 2x minus y is greater than or equal to negative 1. X plus y is less than or equal to 4. And x plus 4y is greater than or equal to 4. Now, all three of these I've already graphed on this coordinate plane here because I want you to see the final step of this. Now, again, what we've done before, you need to graph all three in the same, and you have to actually have all three overlapping. And so where all three overlap, and I'm going to kind of highlight it here in yellow, is this triangular region here. And then the overlap is in here. Okay? Again, it doesn't need to be one or two. The shadings need to be all three shadings where they all overlap and congeal. And so we're looking for the vertices. Now, when we talk about vertices, think back to geometry. Where are the vertices of like a pentagon, right? It's the corners of that shape. And so we've got a triangle here. So what are the vertices of the triangle? It's this point, and this point, and this point. And so all we're doing is listing the 3 points or 4 points or however many points we have on this region. And so this order pair here is at 1, 3. Now pay attention, my boxes are not by 1, they're actually by a half. This one here is at 0, 1. And this one here is at 4, 0. And so my answer would be the three order pairs 4, 0, 0, 1, and 1, 3. The order of those three order pairs doesn't matter. Some will say list them in terms of their x values. Some will say list them in terms of the y values. Again, the order doesn't matter at the end of the day as long as you have all three order pairs. So there's one more example here, example B. Again, graph it up, do the same thing, find where these three intersect and find the vertices. And so that's going to be one of your questions in your Google form. So list those three order pairs that you find for this example. And that's the end for today. We'll talk about this example in class tomorrow a little bit, but make sure you fill out that Google form, make sure you've taken your notes, and I will catch y'all next time.